Section 2.2 is on multiplying and dividing fractions. I have a couple examples of just multiplying and dividing fractions that don't have letters, but I don't know that they're the best examples. So let me just make up an example and show you how I can multiply fractions. First of all, if it doesn't have letters, I can just break out my calculator. I can say this is 6 over 8 times 3 over 5. And my calculator will tell me what the answer should be. This answer should come out to be 9 over 20. When I'm multiplying fractions, there's two ways to go about doing the multiplication. You could either just straight multiply across the numerator, go 6 times 3 is 18, 8 times 5 is 40, and then reduce that fraction. If I reduce the fraction 18 over 40, which my calculator does better than me, if I reduce the fraction 18 over 40, I get that 9 over 20, because here I could just divide by 2 and divide by 2. That turns out to not really be the best way to deal with when we're multiplying when we have variables. When we have variables, we usually cancel and then multiply. And there's kind of two ways you can cancel before you multiply fractions. As long as you're canceling a numerator with a denominator, you can cancel within the same fraction. So I can get this answer of 9 over 20 by canceling first. I could cancel the 6 and the 8 by dividing them by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. And now what I have left is 3 times 3 over 4 times 5, which is the 9 over 20. So when I'm multiplying fractions, I can straight within the same fraction cancel. Equivalently, if I had something like this, 4 over 15 times 25 over 7. I can also, let me do this on my calculator to make sure I know what this equals to. So 4 over 15 times 20, I'm having issues here. 4 over 15 times 25 over 7. That should be 20 over 21. And to get that answer without my calculator, I generally like to cancel and then multiply. One way to cancel is you can cancel within the same fraction if that's reducible. The other way is you can cross cancel. As long as you're canceling a denominator with a numerator, they can cancel a denominator with a numerator in the same fraction or a denominator with a numerator in the opposite fraction. If I was doing this problem to try to get my calculator's answer, I would cancel the 15 and the 25 divided by 5. 15 divided by 5 is 3. 25 divided by 5 is 5. And what this would leave me with is 4 times 5 over 3 times 7. And that's going to be 20 over 21. So the thing that I don't know that I illustrate enough when we get to the section 2.2 is that it's permissible to cancel within the same fraction as well as between fractions. You can do any denominator with any numerator. So if you look at a denominator, you can look directly above it and in the opposite numerator for canceling. So now we can jump into the section. We don't need common denominators when we're multiplying, nor when we're dividing. I'm going to do problem 2. It's not much different than what we've just done, but it has more canceling. So the answer for number 2, since my calculator does fractions so well, if I do 8 over 9 times 15 over 14, trying to get 20 over 21, I'll be darned. Let me cancel. I'm going to take this 8. I look beneath it. 8 and 9 can't cancel with each other, but the 8 and 14 do. I'm going to divide 8 by 2 and get 4. Divide 14 by 2 and get 7. And then I look at the 9 and the 15. Those are also cancelable. I'm going to divide 9 divided by 9 and get 3. 15 divided by 9 divided by 3 and get 3. 15 divided by 3 and get 5. What I'm left with when I cancel is 4 times 5 over 3 times 7. The 4 times 5 in the numerator gives me 20. The 3 times 7 in the denominator gives me 21. The next two problems are division. Let me get an answer for number 4. 4 is 18 over 7 divided by 30 over 21. I should be getting 9 over 5 for my answer. You shouldn't cancel a division problem before you change it to a multiplication. So we're going to invert and multiply any of the division problems in this section. I'm going to change the division to a multiplication by inverting the fraction that's to the right of the division sign. So to get this 9 over 5, I probably can cancel this 7 with this 21. I'll go 7 divided by 7 is 1. 21 divided by 7 is 3. The 30, I could actually cancel it with that 3 and divide by 3. Or I can cancel it with the 18 and divide by 6. I'll divide it by 6. I'll go 18 divided by 6 is 3. 30 divided by 6 is 5. And that's going to leave me with 3 times 3 over 1 times 5. And that's going to be 9 over 5. Matches my calculator perfectly, so I know my answer is right. 5 and 6 are multiplying when both pieces of the fraction. If I was doing problem 6, I'd take the time to make the 36 into a fraction. I just auto-focused. I would probably, well, let me do this on my calculator really quickly. If I did 2 over 3 times 36, my answer is supposed to be 24. To get that answer by hand, I'd probably like to make this 2 over 3 times 36 over 1. I do better in terms of canceling if both factors are a fraction. Now I'm going to cross cancel this 3 with this 36. I'll go 3 divided by 3 is 1. 36 divided by 3 is 12. And that's going to leave me with 2 times 12 over 1 times 1, which is 24 over 1. I don't need to write the fraction because anything over 1 is what the numerator is. So that answer is 24. Now it's just a matter of dealing with the letters. The rules for canceling are the same rules for canceling that we got in P1. If there's a plus sign between a number and a letter, you can only cancel if it's identical in terms of the factor. Let's do 7 together. I think it's a little bit different, and I'm going to start 7 by factoring this 4a minus 20. There's a 1 parentheses factoring I could do in number 7. You might want to pause the video and see how far you could get with number 7. So I'm going to leave the 8a in the left numerator of number 7. I'm going to factor out a 4 from the denominator and be left with an a minus 5. That's convenient because that a minus 5, that's the factor is going to cancel with the a minus 5 in the numerator. And to make the canceling easier to see, the 12a squared, I'm going to write it as 12 times a couple of a's. And now I can up and down cancel or cross cancel. The things that I really want to cancel are these a minus 5s. Now I've gotten rid of all the adding and subtracting. Now it's straight multiplication everywhere left in the numerator, straight multiplication everywhere left in the denominator. I can up and down cancel or cross cancel anything. I can cancel this single a with one of the two a's. And the 8 and the 4 could cancel, or the 12 and the 8 could cancel. They both reduce by 4. I'm just going to up and down cancel. You'll get the same answer if you cross canceled the 8 and the 12 and divided those by 4. I'll divide 4 by 4 and get 1. I'll divide 8 by 4 and get 2. As I scan across the numerator, the only thing I see is 2. I'll pretend I didn't just see something that I should have saw. And in the denominator, the only thing left is a 2a. Well, that's not good enough for an answer because that fraction's not reduced. So I missed that this 12 and that 2 are cancelable, but that's okay. I can reduce my answer a little bit more. I can take this 2 and this 12 and divide them by 2. Since there's straight multiplication in the denominator, I'm free to do this canceling. 2 divided by 2 is 1. 12 divided by 2 is 6. I've made the numerator a 1, but I have to write the answer as a fraction because I can't write a fraction without a numerator. So for 7, the answer should be 1 over 6a. 9 and 10 are enough alike that I don't need to do 9. So in 10, I'm going to do some factoring, and I'm going to expand the x squared just to make the canceling easier for me to see. So the left numerator I'm going to write as 14 times a couple of x's. The denominator on the left I'm going to factor out as 6 and be left with x minus 7. The numerator on the right, I'm going to 1 parentheses Gcf factor, and the common factor is 3. When I factor out a 3, I'm left with an x minus 7. And I still have that 6x down low. Now, one piece at a time, I can start canceling. I like to get rid of the minuses, or the terms that have binomials first. So I canceled out the x minus 7s. Now there's no adding or subtracting left. I can cancel either denominator with either numerator, up and down, or cross cancel. Let me get rid of one of the x's from the x squared with the x by the 6x. Last, I need to deal with these numbers. I'm going to cancel the 6 and the 14 and the 6 and the 3. The 6 and the 14 here I'm going to divide by 2. I'll go 14 divided by 2 is 7. 6 divided by 2 is 3. And in this next fraction, I'm going to cancel the 6 with the 3, because I can cancel any denominator with either numerator, either straight up and down or cross. They both work. In the second fraction, if I divide the 3 by 3, I get 1. If I divide the 6 by 3, I get 2. If I look at what's left in my numerator, I have a 7, an x, and a 1. The 1 I don't need to worry about, but the 7 and the x I do need to worry about. I'm going to leave those written next to each other in the numerator. And in the denominator, all I have uncanceled are a 3 and a 2. I'm going to multiply those because this is a multiplication problem and get a 6 in the denominator. 7x over 6 is a perfect answer, but anytime we have a fraction, if there's no adding or subtracting in the numerator and there's a variable in the numerator, you're allowed to take that variable and drag it off to the right and make it the 7, 6 more obviously a coefficient. 11 and 12 have a trick that I never put on a test. It's the trick that came up in the end of section 2.1 where I needed to line up and factor out negatives. And your problem 11, that needs to be written as negative x plus 3. And then you need to factor out a negative 1 to get going. Similarly, on my problem 12, I need to rewrite the numerator of 2 minus x as negative x plus 2, and then I need to factor out a negative 1. Never do I put factoring out negatives on tests, but I always put them in the homework just because it's a skill that you might see in college algebra. So that numerator I wrote with the x first and the 2 second. Now I'm going to factor out a negative 1. When I factor out the negative 1, the negative x is going to go to positive x. The positive 2 is going to go to negative 2. And I have that 8 in the denominator. I like getting rid of the subtraction pieces here. These x minus 2's can cancel with each other. And now I don't have any adding or subtracting that isn't canceled, so I can cancel freely between the numerator and the denominator. The only thing I see obvious to cancel is this 16 and this 8. I'm going to go 16 divided by 8 is 2. 8 divided by 8 is 1. My answer doesn't need to be a fraction because I've canceled that denominator. It really turned into a 1. That denominator is turned into a 1. So the only thing left in the denominator is a 1. Don't need to write a fraction. Just need to write the numerator without its denominator. And what's left that I haven't dealt with yet is the 2 that the 16 turned into and the negative 1, which was my common factor. And 2 times negative 1 is negative 2. So the answer to 12 is just negative 2. I imagine your 11's a similar answer, but I think your answer to 11 is actually going to be a fraction. I'll do 13 with you. It's kind of a tough problem. Another problem that I'd sneak in the homework, never sneak on a test, because it has crazy hard factoring. Two things I need to factor in number 13 that are a little out of the box is this a squared minus b squared. This is a square with a minus. It fits the category of being a square with a minus specifically because they're two terms, separated by subtractions, and the exponents are even. There aren't any numbers I have to worry about square rooting. So I'm going to fill up the parentheses with two identical terms, except one will have a plus, the other will have a minus. And to figure out what I put in the parentheses, I'm just to divide the exponents by 2. When I divide the exponent of a by 2, I get an a to the first. And because that's before the signs, it's going to lead my parentheses. When I do the same to the b, divide its exponent by 2, I get a b to the first. And because b is after the sign, it's going to end by parentheses. So that's not the hardest factoring. That's doable. The other factoring that's just awful is the factoring in the right denominator. It's not intuitive. It's like so easy, it's hard. It should be a minus b. I don't know if that's looking like a minus b, but it is. The left denominator is not going to cancel. This denominator, the a squared b minus ab squared, I need to think of that. Instead of writing it as a squared b, I'm going to write it as a times b. And then in the ab squared after the minus sign, I think of that as a times b, making the b squared into two b's. When I look at this, this is one parentheses common factor factoring, because on either side of the minus sign, there's an a times b. So that's going to be a common factor. I'm going to factor out that one parentheses common factor of AB. And what I'm going to be left with, after I take an AB away from the double AB, I'm going to be left with an A. After the minus sign, when I take the AB away, I'm going to be left with a B. So the denominator on the right is going to be AB times A minus B. The A minus B that I've created in the left numerator will cancel with the a minus b that's not that readable in the in the left numerator, in the right denominator. The b's up and down are straight multiplication. There's no addition or subtraction left in those fractions, so I can cancel freely. This b will cancel with that b. The only thing I have left in the numerator is an a plus b. Since there isn't any more factoring in the numerator, I'm going to write that a plus b without a parentheses and leave it in the numerator. And a plus b can't cancel with anything but an a plus b. So if there was an a plus b in the denominator, I would cancel it, but there's not. I can't cancel the single a with an a plus b. What's left in the denominator is a couple of a's. I'm going to multiply those a's and get an a squared. So the last two problems would not make it on the test. They're definitely a little too meaty for a test, but good to see for the homework. If you want, try to do number 14. Shoot me an email with your answer and I'll tell you whether you got it right or not. Not the most important problem because it's definitely not going to be on a test. 15 and 16 are division problems. I need to invert and multiply. So before I get going on 16, I'm going to change it to a multiplication by taking the fraction that's to the right of the division sign and find its reciprocal. I can't cancel anything the way the problem's written, specifically because there are plus signs or minus signs between each of the terms, and when you have pluses or minuses between terms, you need identical factors. So I'm going to go ahead and do 4 Gcf factorings. The numerator on the left, I'm going to pull out a common factor of 2 because that's the common factor between 2 and 10. I'll divide each of the numbers by 2 and be left with an x plus 5 in the numerator. The denominator on the left, I'm going to single parentheses factor, and between 5 and 10 I can factor out a 5. When I factor out a 5, I'm left with x minus 2. The numerator on the right, there's a common factor of a 3. And when I factor out a 3, I'm left with an x minus 4. The denominator on the right, there's a common factor of a 3. And when I factor out a 3, I'm left with an x minus 5. I made a mistake, but I'll fix it here in a second. Hopefully you caught that mistake. but this 3x plus 15 is 3 times x plus 5. For some reason, when I wrote this denominator down, I didn't write a 10, I didn't write a 20, I wrote a 10. I must have looked at that numerator. This denominator should have been 5x minus 20 and not 5x minus 10. And when I pulled my common factor of 5 out, that 20 divided by 5 is 4. This parenthesis should be x minus 4. Super easy to do that. I'm sure I've done it times where I haven't even realized I did that, but it is what it is. So now I'm going to go out and cancel. I'm going to cancel the x minus 4 in the left denominator with the x minus 4 in the right numerator. I'm going to cancel the x plus 5 in the left numerator by the x plus 5 in the right denominator. And I'm going to up and down cancel the 3's in the right fraction. They're each going to turn to 1's. So the only thing that haven't turned to 1's, the only thing that haven't canceled is the 2 in the left fraction's numerator and the 5 in the left fraction's denominator. So that's just going to be my answer, 2 over 5. '15 should work real similarly. First step is you're going to change the division sign to a times. You're going to have 3 factorings to do of just common factor factorings. '17 and 18 are divisions, so let's make them multiplications. 18 as a multiplication, I'm going to make it 5y divided by 4y minus 12 times 6y minus 18 over 10y squared. And it's just easy factoring. As we get a little bit deeper into this, getting towards the end of the section, we'll get some bad factoring. I'm going to start off, I'm going to factor the 4y minus 12, just pulling out the common factor of 4. When I do that, I'm left with a y minus 3. The numerator on the right, I'm going to pull out a common factor of 6 and be left with a y minus 3. The denominator on the right, I'm just going to write it with a couple of y's instead of having that exponent. I kind of like canceling like that better. Now I'm going to cancel. Y minus 3's cancel. A single y cancels with a single y. And now either I cancel the 4 and the 6 or the 10 and the 6. I'm going to cancel the 4 and the 6. I'm going to go 4 divided by 2 is 2. 6 divided by 2 is 3. And similarly, I'm going to cancel the 5 and the 10. 5 divided by 5 is 1. 10 divided by 5 is 2. In the numerator, the only non-1 that I have left is this 3. So my numerator is going to have a 3. And in the denominator, I have these two 2's and that y left. I'm going to multiply 2 times 2 times y and get 4y. That y is destined to be stuck in the denominator of the fraction. I can't flip it out of the denominator because it's not in the numerator. If I took it out of the denominator, I could say this. This is 3 over 4 times 1 over y, but I can't just slide it next to the fraction. So I probably wouldn't do that. I think I'll finish this number 20 and then I'll start a part 2 for this video because the factoring is going to get really lengthy in the next few problems, and so I want some extra time. 19 and 20, both multiplications. I'm going to do 19 with you and skip 20, so maybe pause the video and try to do 19. In 19, I need to factor p squared plus 2p plus 1, and I can just sight factor that. Because there isn't a number in front of the squared term, I don't need to do grouping. And to fill in the number parts, I'm looking for numbers that multiply to 1 and add to 2 in their double plus. And that's easy. 1 times 1 is 1, and 1 plus 1 is 2. So each parenthesis is going to get a plus 1. I'm going to leave that factor just like that as p plus 1 times p plus 1 and not write it as p plus 1 squared because it makes the canceling easier. The denominator 4p minus 1, that doesn't factor. There's not a common factor. There's not an exponent. It just stays 4p minus 1. The numerator on the right, the 16p squared minus 1, that's a difference of squares. I'm going to square root the number. The square root of 16 is 4. I'm going to divide the exponent of the p by 2 and get p to the first. And I'm going to square root the 1 and get 1. So I'm going to get two identical parentheses. Leading off the parentheses are going to be 4p's because that's what happens when I do the algebra to the 16p squared. One of the parentheses will get a plus sign, the other will get a minus, and after the signs I'm going to get that 1. So left numerator factors into a 4p plus 1 and 4p, I can't write it right now, 4p minus 1. The denominator of p squared minus 1, that's also a square with a minus. I'm going to take the exponent of 2 on the p and divide it by 2. I'm going to square root the 1 and get 1. This is going to factor into two identical parentheses, one with a plus, one with a minus sign. Before the signs, I'm going to get p's. After the signs, I'm going to get 1's. Now that I have everything factored, I can go into canceling mode. The left denominator of 4p minus 1 will cancel with the 4p minus 1 in the right numerator. A p plus 1 in the left numerator will cancel with a p plus 1 in the right denominator. That's all the canceling I can do. In the numerator, I have both two terms or two factors that aren't canceled. I'm going to leave those multiplied. It's actually preferred not to multiply those out. So you could FOIL those out, but it's better to leave them factored. And then the only factor in the denominator that didn't cancel was the p minus 1. And I'm going to leave that in the denominator, but I won't need the parentheses anymore. So we have just like 10 problems left, probably 5 evens and 5 odds. But I'm going to pause and do a part 2. We're at 27 minutes. I bet you it's going to take me 20 minutes to do those just because the factoring is a little more difficult. But there really isn't much new after this.